Okay, welcome back, everybody. We're going to start the final panel to wrap up the day. The moderator is Sujay.
Okay, that's it. Thank you. I hope you got your last fill of coffee. I'm very excited to have 4 great panelists. Let me briefly introduce them. Our first panelist is Ariela Zierra, who's the head of technology planning and strategy at Intel. And she was previously a VP of engineering at InterDigital, and she has a PhD from Yale and a bachelor's from the Technion. She's a very well-regarded and widely cited inventor with over 200 issued patents. Our next panelist is Jin Yang. Could you guys wave? Thanks. He is the senior director at Huawei, where he leads the applied machine learning in network and services group. And he spent over 20 years in the industry at Lucent, Motorola, and Huawei. In Huawei now, he has a pretty broad spectrum of things he looks at with the task of using ML to better services, to have better user interfaces, and everything in between. Steve Kettler is a VP of architecture at NVIDIA. He's also local, although I guess he has teams in many places. So he focuses on a domain-specific massively parallel hardware design at NVIDIA. He was previously a full professor here in CS at UT Austin, and he's a fellow of the IEEE, ACM, and the Sloan Foundation. Our final panelist is Xinjiao Wu, and he is the head of autonomous driving at Qualcomm, which they have a big effort currently based out of San Diego. He was previously at Qualcomm, New Jersey, where he was a part of a team that made fundamental innovations in peer-to-peer and vehicle-to-vehicle communication. He's also a key inventor at Qualcomm with over 160 issued patents. So I'm very excited to hear what they have to say about the intersection of AI and machine learning. So as opposed to the first panel of today, which was focused on the use of machine learning to get better wireless and better communication systems, the focus of this panel is more about what are the challenges for AI and what are the challenges for the systems that support AI. So the way we're going to run it is we're going to have about 45 minutes of a discussion with our panelists, and then I'll open it up to questions. Okay. Here's maybe the first question to get us started. In a few quick words for each of you, can you think of one AI application that excites you the most? And for that application maybe, or even more generally, what do you think is the main resource or system design challenge that we need to make this happen? So maybe we can start with Steve.
Sure. So thank you, Sujay. I really appreciate you inviting us here. My broad class that I think is really interesting, of course, is autonomous machines, and that can be applied to many domains, whether it be transportation, healthcare, manufacturing. I think some of the challenges there are these machines need to operate in uncertain environments, interacting with things that are not machines. We were talking a little bit about V2V in the last presentation, and while that certainly be nice, it takes a very long time to turn over the automotive fleet, and so having every vehicle be wired in is going to take a long time. I think the other challenge there is in those environments you really have to be learning with less data. It's not like you have an enormous corpus of images you can just train on. The environment is constantly changing. So I think we're pretty excited about some of the techniques around reinforcement learning, but that whole space is one that will require a lot of research.
Hi everyone, and thanks for inviting me to be in this panel and the whole event. So what excites me about the application of AI is actually this trend to make the human-machine interface more personalized. There is a trend going towards direction. And so just an example, people are talking a lot about autonomous driving, but within the safety envelope of autonomous driving solution, there is also the personal matter. What is the driver personal driving style? Is it more aggressive? Is it more conservative? So can we just learn more about the driver to make the decision that are still within the policy and the safety, that it makes the driving experience more suitable for the person? This is one example. Another example is actually in gaming. So, I'm not a gamer, but talking to gamers, I know that many people, if they are playing a game, if it's too difficult, they get frustrated. If they are, it's too easy, they get bored. So can you really tweak the game to the exact same difficulty level that really matches the So that's another area that really intrigues me is again, healthcare is often mentioned in the context of AI and machine learning, but we are talking about diagnosis and things like that. I mean, what intrigues me is, can we improve the quality of life of people, older people, the baby boomers, just by having technology at home and using AI, not just to let us know that a person failed, but to be able to predict the likelihood of falling and then take prevention measure, or to detect cognitive decline and things like that. I mean, all those applications and other, to me, the main challenge is actually as it related to network, one of the main challenges is latency. Mm-hmm. And it's true that URLC in 5G is doing the steps in the right directions. The question is, can we really get to the performance of Class C, which is sub-millisecond latency? And then another things that intrigues me a lot of this application actually happens at home with Wi-Fi. So can we match the latency that now we have at 5G URLC on Wi-Fi? So thank you.
Thank you. Please.
Good afternoon. So honored to be on this panel. As Suji introduced, we're in Huawei here as a research center. We're looking at how AI or machine learning can help the network. So actually, my research interest is more on the most morning track. But I think a lot of issues are common. So one thing, a lot of things make me excited from, very cloud type of application to edge or device. One thing I'd like to highlight is the network self-optimization. Yeah, you probably heard the concept or the term called SON, self-organizing network, which has been, in the standards for many, many years. But really, that's just a vision. There's no much progress. We think now with machine learning, with a lot of data available, now we have a chance to really push forward towards that vision. Also, the business, the requirement is clearly there, right? Sometimes I was joking. I said, if you look at cellular system, now we're in the 5G era, or even someone talking about 6G. However, if you look at how the network is being managed, operated, we're almost at the first generation age, right? Nothing really changed since early days. So I think it's operator really has a pain on that. We met a lot of customers. They said, hey, now we need to manage, operate at least 2 or 3 networks at the same time, right? UMTS is all there. Some, GSM is still there, right? Now we have LTE, now 5G. I would not be able to expand my, operation team, double or triple. Actually, we're trying to reduce that. So really, there's a business need there. However, talking about the challenges, so actually, it's still the data issue. I was talking to Dr. Gosh this morning during the lunch. So I said, will the operator mindset be able to change so that they're more willing to accommodate, some of this, when you do the optimization, you need to play around with, for example, the parameter setting and so on, explorations. Today, every parameter change need to go through a very, series of approval process, right? So to generate one data point, right? For example, I change the parameter from 0 to 1. That is really hurting us to solve that problem. So if there's any idea from you guys, we'd like to hear that. I just use that one as one example. Thank you.
Okay. Jin.
Okay, I work in the autonomous driving field, and obviously deep learning is so important, and essential to this whole field. There's probably many examples I can give, what are the key problems we're working on. The good thing is Iran's talk probably give you guys a pretty good overview of what are the deep learning applications, in autonomous driving. So let me just name one thing. Obviously, different companies have different focus. And in Qualcomm's case, what excites me the most is basically using deep learning to solve the camera plus radar perception problem. The reason being, basically, in Qualcomm, we are, working with the auto OEMs, try to enable level 2 and level 3 autonomy in the consumer vehicles, where LiDAR is probably too expensive and to some extent impractical to deploy in any near future. So we have to have the capability of developing a perception capability just using very cost sampling using radar, and 3D projection to 2D plane using camera and that's your input, and you need to basically recover the very accurate 3D information, both semantically and geometrically of the world around you. And that's, to me, the most exciting problem, okay? And in terms of the challenge, basically, just to give, again, a few examples. So in the radar-based perception and how to use deep learning to basically produce better results as compared to signal processing, that's one of the area which is very interesting. Then basically on the camera side, basically one of the key, let's say, challenge, at least for Qualcomm, is basically how to, as you guys know, deep learning is a very over-parameterized problem. And, our mission is really trying to deploy these networks in Qualcomm device with limited compute resource. We need to be very compute efficient and power efficient. This is the mission. And essentially model reduction and try to basically make the network model as simple as small as possible, which still give you outstanding performance. This is the main challenge. And the one angle we are looking at it, obviously, if you guys have good ideas, this is very good topic for future collaborations. One particular direction or challenge we're looking at is basically how do you using temporal information to do more efficient deep learning inference, especially the autonomous driving perception problem is actually a video processing problem, not a still image, basically inference problem. And most of the estimation right now from the industry is based on you have to get to 30 or 60 FPS still image processing, which you are actually throw away all the basically temporal information along the way. So how do we basically do more efficient and utilize the temporal information from previous images or network result to get to a much smaller processing capability and to enhance the efficiency over the perception network, because that's one of the very interesting problem and also challenge for us.
Okay. Yeah. Thank you. So should we move on to the next question? I guess the next question is that do wireless systems need to be redesigned for much greater, to be much faster and to be much more resilient than maybe what they are now, if they are to support AI? So we heard several talks, including the keynotes, about kind of AI in mission critical applications like surgery, right? And if the data is being communicated over wireless, are wireless systems up to it, or do they need to be changed? Or is it the fact that the current technology paths are good enough, right? So if I were to summarize my question, it would be that do we need to think of AI and communication as a joint problem that needs to be solved? Or can the two worlds remain apart and it's fine? Because wireless is anyway trying to become faster, and AI is doing its own thing. So maybe we can have Jinyang start.
Firstly, I'd like to probably clarify this question by saying that the AI, when we talk about AI, actually it has two levels of applications, right? First level is AI to help the network itself, and then the AI to help whatever devices or application layer stuff. So I think this question is more on the second level. I'm having a conflicting view on this. Sometimes I feel, it can be designed separately. Just using an example of, for example, IP versus IP-based applications, right? Right now, cross-layer, optimization is not that common. For example, there are some research or papers talking about that. For example, how the underlying IP network can be, jointly designed together with the application, but in most cases, these two things are separate, right? For many applications, for example, even video type of real-time application, they just assuming underlying IP transport is such that they adapt to their behavior, whatever QoS, or manage QoS through the application layer. So if that approach still works for the AI type of application, then yes, we can do that separately. On the other hand, we may not be that lucky, so we have to do the co-design. One example is Aaron's presentation just now, for the self-driving, right? So certainly, if a network-assisted self-driving solution seems, better if it's there. So in that case, for example, we have to support local networking, either D2D or through infrastructure, so car-to-car communication is, more reliable or efficient. Also looking at IoT or advanced, manufacturing, right? So that require some, certain requirement on the wireless network as well, instead of just a, public cellular system. So I think the answer is probably we need both. That's a short one.
Okay. Anyone? Ariella, why don't you?
I have the mic, so. I agree with the way you said it depends whether we are using AI machine learning to improve the network or devices or the applications. So I agree that we have two classes of questions, but I think actually I also would like to refer to the first part that we actually use machine learning to improve networks and devices. And we had very interesting presentation early today by Tim, I believe, regarding this end-to-end vision of machine learning. And this is very intriguing because, it gives you the capability not only to design the best receiver that you have, but also the best transmitter. So it's very intriguing, but I see here a completely change of mindset in the way we standardize, right? It's very easy to standardize a waveform that everyone uses, or class of waveforms, and then the receiver design to optimally process this. But I mean, I think it will be a tremendous challenge to the standardization, really, how, if we look more global end-to-end approach, how we standardize these, how we interoperate between multiple vendors. So to me, there is a lot of promise in this end-to-end, but the challenge is really how we can, I mean, standardization is just a way to enable interoperability, which is so important. And so that's the first part. The second part of the question is really to use how the application of AI on top of networks. So, I mean, there is this trend that we all recognize, especially with 5G, and which is the densification of the network. And we have now multiple nodes that each of them has, including the device, considerable computing capabilities. And we actually can, and this is related to the other presentation regarding machine learning at the edge. So the edge is not one node, it's a collection of distributed nodes. And since each of the nodes has considerable amount of processing power, I think that the challenge is actually to develop methods of distributed compute, right? And there are major challenges there related to latency, reliability, how you jointly optimize the split between when you make a decision, do you process it locally or do you communicate it to another node, and things like that. To me, it's one of the major challenges.
So, yeah, I mean, I think you really have to sort of consider the application, right? I mean, there's certain applications where, where safety is paramount and the network is a part of that. Well, then your network is really in that domain. Now, I don't know about you, but my experience with my phone or any other wireless device I own is pretty poor in terms of reliability. So I would not rely on those for safety at this point in the game. And oh, by the way, that doesn't even account for potential adversaries who might want to defeat infrastructure that relies upon wireless communication for safety or other things. So I think there's we probably need to separate the world into those things which interconnectivity is an augmentation or an enhancement of capability versus where the interconnectivity is critical to the functionality or safety. And I'm far more comfortable in the former, given what we have today. I'm not comfortable with the latter, but this is not my area of expertise.
Pass. All right, yeah, it's fine, pass. Okay, so thank you for your perspectives on that. So I guess the next question is something that is maybe not a thing that any of us or most of us think about, but which I personally feel that we should as people who work in AI or in technology more generally, and which has to do with privacy, or more importantly, the lack thereof. And so I guess this question is maybe a question for you, or maybe a question for how your companies think about privacy, or do they think about it, or do you think it's not worth thinking about? And so I guess I had to write a sentence, but that was my thought. And so my sentence is, how do you think privacy concerns will shape AI and mobile applications like healthcare, autonomous cars, and things like that, which have, which are collecting, arguably intensely personal and very real-time data, right? Am I happy shipping it to some third party on the cloud? But if I'm not, then maybe I don't get good AI and I don't get good results. How are we navigating this space?
Sure, this is an excellent question. And actually, moving forward, the car company are going to have a lot of data. They will know a lot about you. Not yet, but for example, Tesla is already there. They actually, I read this news recently, somebody just had an accident, and in like 5 to 10 minutes, he got a call from Tesla call center asking if he's okay. It's a good thing. It's a good thing. But just think about, because car makers will need to have the data from your car to keep improving its model and improving the performance and the service in the Tesla case. But they will essentially know where you are at any time if the data is not, let's say, used properly. There's certainly privacy concerns here. So fortunately, I don't see it as a Qualcomm problem yet. That's a lame answer, but I really don't have a good answer here. But I think this is something for autonomous driving, at least, moving forward. Again, there will be a lot of data need to be collected from the car, and which will be shared at least by the car maker. Probably when the user like me, I bought a Tesla recently. We just click through and sign everything. I don't even know what I signed. So some probably regulation again, it's a lame answer, but some thoughts definitely need to be put in here to protect the privacy of everybody. I think in the near term, probably convenience will outweigh privacy. But as we know, as the world evolves, there might be some issues rising from abusing the data. Then basically, at some point, government might have to step in, and industry as a whole might need to put on some regulation. But I don't think this is, at least for now, we are still in the phase of solving the technical problem first. It's not at least I haven't actually heard too many discussions on this topic, but it's a very interesting topic.
Okay.
Yeah, just to add that from a network perspective, the network data we're using or training is more, it's not a user level data, right? So from that perspective, we're slightly better situation in terms of the immediate privacy concern. However, down the road, we still think there's an issue there. For example, once some of the more decision making in the network is learning based, then the model we continue to learn to train using customer A data. Is that okay? We use that model for customer B in the next software release, for example, right? So that type of issue certainly will arise, but it's still too early to tell. On the other hand, I think techniques such like privacy reserving training, like Ms. Zhou just presented, would be very important and interesting to us. Yeah, thank you.
Okay.
Okay, so the title for this panel is where we should do AI. Is it on the edge or in the cloud? And I think it's obvious that the answer is not either or. Some of it will be done in cloud, depends, and some of it will be done on the edge. And then where it's done is really based on the actual application and requirements. For example, low latency will probably move it more towards the edge. And so, and then privacy is actually another factor that will make machine learning closer to the edge. So for example, if we go back to healthcare example, but healthcare at the home, right? So the edge in this case could be a device at home, and then just subset of the information is delivered to the cloud. So obviously, I think that the privacy will actually push things more towards the edge. And then there was also another interesting concept that was by Xiaxing, the speaker from Cisco, instead of using real raw data, using GAN models. And this is another way to address privacy. Okay, thank you.
So I'm going to agree with Ariella. I think this notion of splitting between cloud and edge is an opportunity for to address some privacy issues, and some of those things may actually come up in a regulatory fashion. Different societies have different expectations of privacy in public spaces. Some societies are perfectly happy collecting all sorts of data and delivering it to central sources and processing this and judging and assessing people finds based on their actions they observe. Other societies, really are more concerned about preserving privacy and may decide that they do not want any raw images coming off of distributed cameras in a smart city, for example. In which case, really the challenge is how do you, define, the synthesized or metadata that can be used for such intelligent applications without sacrificing, identities or things like that you might be seeing.
Okay, thank you. Yeah, I do think privacy is very important, and as technologists, we should think more about it. So thanks for your perspectives. Okay, so. The next question, does there need to be a GPU on my phone?
Yes.
In related news, Steve Kettler from NVIDIA. So what I mean by this question is, do we need, if you have very small form factor devices like phones or even smaller embedded devices and things like that, do we need specialized hardware for AI? These devices are going to have processors anyway, right? And are those processors good enough to do basic AI? And if anything that requires more, we should be doing it maybe in the cloud or maybe using communication more. And so I guess the idea is, if I were to ask a specific question, is should there be specialized hardware for AI in very small form factor devices? Maybe Steve, since you really want it, you can justify why.
You got to make these things fun and get a few laughs. So, so this is probably the one question that's most in my wheelhouse. I think the way I look at this is that there's sort of two competing challenges. One is energy efficiency, and the other is programmability. Okay? Basically, every system out there today is energy limited in some way, shape, or form. Could be battery based, could be performance is limited by cooling, whatever it may be, right? Given that Moore's law and Dennard scaling is over, one strategy to increase efficiency is through specialization, right? That's just a fact. By the same token, we are still very early in this world of AI algorithms, and of course DNNs are not the end-all be-all to machine learning algorithms and so on. And furthermore, a DNN doesn't necessarily solve everything you want, right? You're building it into a system. Maybe you actually do want to, be able to do video processing. So you need to be able to, do, segmentation, or maybe useful to have optical flow or things like that in your pipeline. I think my take on this is that we will see greater specialization. The specialization may not necessarily be, unique accelerator blocks, although that certainly is possible. Certainly, processors, programmable processors can be augmented with extremely energy efficient, high performance computing capabilities. I can certainly point to our tensor cores in our recent GPUs. We have a energy efficient programmable parallel system, but augment with sort of this booster pack of linear algebra acceleration. So I think that it is likely that at all scales we will see some degree of specialization. Whether or not exactly how much you need, how much performance you need, will dictate the type of deployment that you're willing to, the type of machine you're willing to put in there. So I may come back at the end. We'll see.
Okay. Please.
I have to agree with you. And I think the question was, do you need really, can we get away with the GPU, or do we need specialized hardware? So I would like to give one example, right? So suppose we want to have, and people are talking about this, even AI capability in very low, devices with very low processing capabilities, like in IoT, right? So I think my colleague Nagin has mentioned that Intel has developed the neuromorphic chip, which is really an example of very specialized hardware that is based on different kind of neural networks, spiking neural networks, and the idea that it's not just sequential processing, it's event triggered, and that's why it's very low power. And it's intriguing to see, I mean, what other applications we can use this. And then another example, and I'm naturally also very interested not in just applications of AI, but how we can use AI to improve devices and networks. So there is research that shows that you have, let's say, a DNN, fully populated DNN, and it can do as good as a certain function of the modem, whether it's data detection, channel decoding, channel estimation, but the network is large, it's huge. The computational complexity is big, so the question is, can we come with very efficient structure that still achieve the same performance, but significantly less, size and processing load? So, yeah, I'm a strong believer in specialized IP.
Yeah, I think this is an interesting but also difficult question. On one hand, I think, as you probably know, Huawei has put this specialized AI chip in its high-end phone. On the other hand, I think we're still in an early stage to see how much value or application will benefit from that. Also, as an end user, we appreciate that, right? We're willing to pay the cost. I think we're still in the early experiments stage. Similarly, for example, from network perspective, we also has that dilemma as well, right? So, for example, if we need to do a little bit more of the AI into the base station, then we have an issue of we need a hardware, right, to support that. And then it's a chicken and egg, right? On the one hand, you say you show me the value before I give you the new hardware or data. On the other hand, if I don't that, I cannot show you the value, right? So I think, yeah, maybe we just go some experiments and then to see which one is the answer for this question. Yeah.
Okay, I guess we are pretty much in agreement. It's probably disappointing for Sujay. The panel is getting a bit boring.
I'm agnostic to it. Yeah, I mean, I would like to see some more fighting, yes, but
Okay, so obviously, I don't see deep learning accelerators that much from computer vision CV processor or a computer vision accelerator where we do DFS and optical flows, these kind of things. And it is very common, even in phones, at least the Qualcomm chip, we always have a CVP, a computer vision processor in it. And we are also basically bringing the deep neural nets basic accelerator in phones. And I think that's the right approach. And obviously, we will make it programmable for other use cases as well, just in case, basically, DSP. Actually, we are going to combine the DSP and neural processor together, call it NSP, neural signal processor, essentially. And for the other side, for what I'm working on for autonomous driving, and obviously, it's a sort of very specialized chip, and having massive deep learning capability is critical. And being able to reduce the number of joules per top is one of the key goals. And I do believe having specialized accelerator and a massive amount of them is very critical.
Okay, I guess the answer is yes. All right. Do you have any last? Okay. Okay. Yeah. All right. Yeah. I mean, I had to make 5 words. Okay. Yeah. All right. Moving on to the next one. So this is going to the cloud side. So even just doing AI in the cloud is already extremely expensive. I've heard friends in the industry tell me that many of the biggest companies like Amazon, Facebook, and so on, think they need to do AI or already do things like image labeling and tagging and so on billions of pictures every day. And that's an enormous use of resources. Right? And so I guess the question for our panel is, what are the key, maybe not all of them, but maybe each one of you can choose one of what do you think are the, is an issue or a key challenge for doing AI in the cloud, not on the device. Because even AI in the cloud is already a multi-billion-dollar problem. Right? So I don't know, whoever has the mic can start or not. All right, let's start with Huawei.
Yeah, just a simple point on that. I think there's a lot of challenges, but the one thing I'd like to highlight is that I was reading something recently. It's trying to compare from 2012, right, AlexNet, and to this year, the AlphaGo and Zero and things like that. So between these, different network training, the computation requirement is 300,000 times. So certainly that is not sustainable for any, even big company. So I think that presents an issue of, how we can make the learning, training more efficient, right? The computation-wise, the data-wise. So I think that's maybe as academic research topic as well. Someone I heard commented that, for example, the stochastic gradient descent may not be the way to go because that's very inefficient in computation and optimization. So I just like one issue.
Okay, I think so. AI in the cloud is really what's done now in data centers, and I cannot quote numbers, but the power consumption of data centers can actually be in the order of like a big city somewhere or a medium-sized city. So I think that power consumption is one, but also the fact that all this information is concentrated in one place it makes it very vulnerable to attacks. And I think that the solution is actually getting away from the cloud and more towards distributed compute. So yeah, this is my.
Well, most of those cloud service providers have, multi-sites that are geographically distributed and they do data replication for availability. What do you think about that? Is that a reasonable solution, or do you think that further distribution is required?
Yeah. I mean, yeah, it actually probably can address the vulnerability issue, but we don't consider each problem in isolation. So if we also consider the latency and the privacy, then actually, probably distributed approach is preferable.
Yeah. So if one of you maybe starting with can also comment about, there's training and inference in AI, right? Like you can train neural networks, but then you have to run them, and both can be expensive. So if you can comment about that as well.
Yeah, so I think there's sort of a broader issue here, and it has to do with data center design and how you provision it. There's commonalities between that and HPC installations. If you go to a high-performance computing center and plot their application, most popular applications are being run, it's a long tail, right? There's like 15 or 20 that account for maybe 80% of the cycles there. But then there's like another 1,000 that takes to get you to 99%. Cloud data centers are similar, right? So, building a data center that is so specialized that it can only do training, or only do inference, or when it does one or the other, it uses the resources very inefficiently, is a challenge. Right? There's a lot of value in being able to have a more homogeneous data center so that you can actually be flexible in how it's being used. In general, the challenges are somewhat different. In training, you typically don't have a latency constraint. You typically have a very large number of a large data set you're trying to operate on simultaneously. There are algorithmic challenges to scaling that to a large number of distributed systems, and there's some system challenges there that people are actively working on. On the inference side, of course, it's far more latency sensitive. That tends to drive batch size down. But the flip side is you have a lot of independent tasks. So the desires are slightly different. There's this question of, over the long haul, where are we going to be spending more of our cycles on training or on inference? For sure, you'd think it would be inference, just because there's a lot more that to be done per unit of training. To date, that's not obvious that's been the case. I will bring up one other challenge associated with data center-based machine learning and AI, and this is that of security. And this comes in many flavors. Privacy is one aspect of that, but then another one is really sort of protecting intellectual property. There's actually, if you own the data and you're able to train your system based on that data, the neural network that encompasses that task is extremely valuable to you. You don't want the parameters or the structure of that network to be leaked out so someone in some Caribbean island can just replicate it. But there's a lot you can learn by actually querying that system, right? You send it images, you can find out what actually is being done. So I think that's actually a really interesting question of how do you actually protect the intellectual property that is embodied in these things. That's just one example of security. There's many more. I think these are difficult challenges. These are things that we are worried about. We actually are quite worried about our intellectual property in self-driving networks, and are worried about those of our customers. And it's not obvious how those problems are going to be solved.
Okay. Anybody?
So for AI in the cloud, obviously many big cloud players are building specialized hardware as well, just to address heat and the efficiency issue. I think this is in public. Both Google and Google had TPU, and Facebook is working on something as well, which is not very surprising. So one challenge here is probably similar to the specialized hardware we are making for autonomous cars that way, in the sense that deep neural nets are still evolving very, very fast. Every 3 months, 6 months, basically you have new architecture coming out, and how do you make the right mix of, let's say, general programmable, basically, hardware versus specialized one? How do you mix the two so that the hardware can be more future-proof? That's one probably interesting topic. And so in terms of basically training the network versus the inference, I just want to mention one of my own experience. Actually, right now, to train the network using Google Cloud or any cloud service is still way too expensive because you need to really run the, make the backpropagation to converge. You need to run it for days, if not weeks. Actually, right now, my approach, at least in my teams, we do training locally and do inference in the cloud. That's, at least in the near term, that's a feasible way for me.
Okay. Yeah. Always good to follow the money to answer a money question. Okay. Yeah. So moving on to the next one. We heard quite a bit about autonomous cars, right? And so I guess one more question about autonomous cars. So the specific question here is, there are many AI problems, and there are many places that we need to use vision, or we need to integrate sensors and so on. But maybe Xinzhao is the best person to start answering this, which is, what is it about autonomous driving specifically that is hard or challenging, as compared to the general field of AI?
I think, again, Yaron's talk addressed some of these, address this topic regarding wireless and AI systems, in autonomous driving. So I just want to maybe add one thing to this question, which is basically on the driving policy side or behavioral planning side. Autonomous driving, actually, it's quite different in the sense that, as compared to perception, it's usually a supervised learning problem, and you have tons of data, and you can develop the network offline. But for autonomous driving to work well in terms of using reinforcement learning-based driving policy, this kind of approach doesn't work. You have to take the vehicle, to the field, which itself is very challenging because, you need to get to a normal human drivers like one fatal accident every million mile or every 10 million mile, around that range. So to get to this kind of same robustness, obviously you cannot do this, test this kind of feature, reinforced learning based feature on the road. So simulation become very, very critical. I think this is probably a pretty unique demand of using deep learning for autonomous driving. Okay.
Okay. Does anybody else want to chime in about autonomous driving?
So I agree that, autonomous driving is unique in the sense that the cost of mistakes could be very high and fatal. And actually, doing like millions and millions of miles is not scalable, it's not practical. And I think I would like to relate it to a previous discussion that we had today. So should we keep networks that has AI to higher standards than networks with traditional methods? And I think yes, even if we mature autonomous driving, and statistically, the accident rate and fatality rate of autonomous driving will be lower than current standards. Still, any fatality will cause a significant setback. So I think just it's the nature until it really gets really more acceptable, the standards for autonomous driving will be actually higher, and fatalities will not be tolerated. And I think, this is just one example where the technology is a little bit ahead of regulation and ethics, right? So we had similar discussion in the context of social networks. The technology pushed them ahead of society, and I think autonomous driving is just another example for this.
Yeah,
so to me, regulation, liability, not so much technical issue are the actually quite big challenges towards autonomous driving.
Just very quickly, safety and its implications to verification and validation. Machine learning and neural network design is still very much of a black art. When something goes wrong, it's very hard to say why. And that's why there have been some programs, and DARPA has a program, for example, that's focusing on understanding AI, and things like that are very challenging research problems that need to be solved.
That's right, yeah. So making it safe and making it explainable is important. Okay, so I think in the interest of time, I will skip the last question. I wanted to know your views about augmented and virtual reality, but we can have that offline. Maybe I can have each of you give some brief closing thoughts, maybe for a minute or so, if you prefer.
I'm going to pass. I want to hear the questions from the audience.
Okay. Yeah, we're going to switch to that.
I wasn't really planning to give any closing thoughts, but actually I'll say something. I think this is just from the point of view of research and innovation. This is a super promising area, and we are at Intel are really excited to embark on this area. Not just application of AI, but actually how to make networks and devices work better. And I think we have a lot of hope in this area and encourage a lot of collaboration in the academia and industry.
Okay. Cool.
Yeah, actually, I don't have a direct answer on that. I'm not following the AR or...
no, we are not doing this question. Yeah, if you just have some final thoughts about other questions.
I think I will pass on. Thank you.
Yeah.
All right, so Sujay's title for the panel is basically edge or cloud, where the AI should happen. Obviously, the answer is both, and it's a extremely exciting time to see AR. Making so much difference without actually, especially for deep learning, I think our understanding towards it, I'm communication background, we engineer the heck out of it. We know every bit, regarding the communication link, how things should be done. But AI, it's pretty far away from that. But on the other hand, it's already generally so many beautiful results for so many different use cases, really, really exciting.
Ask first. Okay, so Steve, you mentioned that we may have that you don't want to give away. One might not want to give away the details of what's inside the parameters, even the architecture. And so now the question for anyone who cares to answer is that, do you think that we will be buying and selling these machine learning black boxes? So would your company expect someone else to buy a black box that has some stated performance, or would your company, for your product, buy a black box and put it in your autonomous cars? And if the answer is yes, then what kind of specs would you expect to see?
Well, I think there's many different types of organizations out there who want to deploy AI. There are some who are very sophisticated and, quite frankly, just want to buy bare hardware and layer everything on top of that, right? There are others who are not sophisticated at all and really want to buy a solution. And so I think the marketplace is going to fulfill all of those needs over time, and different types of organizations will help fulfill those needs. I think the specification. It'll be an interesting question to see if there really is a generic appliance. We actually tried this with a box called Digits, which it sort of came with, a machine learning platform. You can put in a few parameters, and all of a sudden, boom, you had an image recognition system. I think we found that people have the types of problems people have are far more diverse than that. And it's likely going to require more of a collaboration or a services-oriented experience to deliver what the customers will want.
I think that's a big question. But in short term, maybe one thing can help at least for some experiments to continue. I think last year I heard a Microsoft presentation. It's called Data Sheet for Data Sets. Basically, she was addressing this from a different angle. Basically, she's talking about the buyers and so on. But look at the robustness perspective. I think we all realize from the whole day talk that the data-based modeling or learning-based approach right now has this generalization problem or robustness issue, right? And, when you see the data outside your training set. So one thing I think maybe we can do is if we can identify a way to see this model is going to operate well under these conditions, right? For example, when we buy a hardware, whatever, you say, oh, the operation temperature is between this and that, right? So similarly, if we can find a way systematically to describe what the data set or the model is good about or is suitable, then I think that certainly help to move one step further.
I'll come up to you.
So somewhat related question, given that there is a lot of secret sauce in developing AI solutions, and we are trying to now design end-to-end systems, and Ariella raised the issue of standardization. So would you see an increasing trend towards vertically integrated solutions like we used to have a long time back, Like if you look at the cable industry, they sell you network hardware, device hardware. So would we see an increasing vertical trend towards vertical integration as a result of this AI trend?
I think we already have, right? I mean, if you look at the large cloud service providers, they're all trying to build their own hardware, right? Google has already built, their own TPU. They've, have their own software that runs on that. They are selling AI as a service, as a very vertically integrated system. Microsoft's trying to do the same thing, currently based on FPGAs. They may choose to, to ship gears. So I think the vertical integration is here already.
Well, it's a difficult question. So basically, standardization is not for the sake of standardization, it's for the sake of interoperability. So how we make sure that AI solution that works in the US also work in other places in Asia and places like this. So I think somehow we need to overcome standardization and interoperability. To me, it's one of the big challenges. And as you know, I'm still looking for an answer there.
As a network vendor, I think we start to see the requirement, right, to have a more specialized solution for some verticals. But I think that the biggest challenge is that how much, business value there, so we can justify the investment to go, and also how far. So one way, I think, is kind of a hybrid. Right? We have a lot of things in common, but then certain modules, software, hardware-wise, is tailored for certain, verticals. I think that probably a good compromise.
It's the question for you. Do you see network slicing as an enabler? So basically, you just give a slice to an over-the-top provider, and they do whatever they do, and they don't need to standardize?
Yeah, slicing has been quite a hot topic for some time. I think, certainly it's a good concept to support different vertical, different type of SLA, and so on. But I think it's still quite early to see how that concept or vision can be supported effectively into the network. I think, it's still in the early stage. Yeah.
Thank you. I was wondering if the panelists could comment on incremental learning. Basically, you train your favorite classifier to do some set of distinguishing between a bunch of classes. But in these like wireless or autonomous driving, right, the real world is much more complicated. And suppose I want to, I identify a new category. I don't want to retrain my classifier all over again. I just want to incrementally, just train the delta, and it should continue to work as before. But learn to recognize the new feature I added, the new class I added. Could you comment on where the state of the art is with regard to incremental learning for wireless or autonomous driving, and how it factors in this edge versus cloud debate?
Okay, that's a good question. So in terms of autonomous driving, I think the industry have defined different levels so that we can make progress, gradual progress in having feature by feature, basically, addition to the capability, so that we can reach higher and a higher level of autonomy. So go back to your question is basically like between level 2 and the level 3. Let me not try to bring the level definition here, but essentially in level 3, for example, we need to have a much better understanding about the semantic information of the vehicle. We have to differentiate between a truck, a car, a sedan or a motorcycle or a bicyclist. As compared to in level 2 perception, usually you can label everything as a sedan. And also, basically, you might want to have to, let's say, blinker states. You need to understand if the car is braking or not. So obviously, this is as compared to the just draw a bounding box of a vehicle. This additional capability you need, and usually, basically. I'm not sure if I can represent state of art on this, but a typical approach, at least my team is looking at, is you can add a different detection head on your network. And you are obviously not going to throw away, let's say, your level 2 network parameters, but you can, when you have, let's say, you now want to add the vehicle, let's say, heading your direction as part of a network, then basically you can retrain with new data, with new annotated data set, you can retrain the addition you just put in the network, but you can maybe keep your base net what you used as before. So there's a lot of heuristics we can do here. Obviously, the training, for at least for autonomous cars, it have to happen offline. I still don't see that we will do the training and with the added capability, self-learning kind of capability in the vehicle anytime soon.
Yeah, a quick point to add. I'm not talking about from the self-driving car context, more from a network aspect of the application. One thing related to your question is, how can we do very fast adoption of the global model to the local condition? Basically, look at cellular network, every location of cells very often present a unique behavior or model, if you like, to be adopted or modified according to the global model. Right now, we still trying to find a way to, because current measure typically take a very long time, a lot of data samples in order to the model to kind of steer away, towards the local condition. So we start to see research papers to see how you can, very fast adapt to the local condition. That's certainly a very interesting research topic area we'll be looking into.
Any more questions?
So if the panel is finished asking the last question, I'd like to take the panel back to when NVIDIA answered the question about vertical integration. There's quite a delay here, isn't there? You mentioned that Microsoft and I think you were saying Amazon are building different type of data center, and that implies vertical integration that's separate. But that doesn't make any real sense to me, since they're building a data center to service multiple vertical industries. So maybe our discussion of vertical is among, our definition isn't quite right. So maybe I can hear from the panelists about, are you really planning to build a separate AI box for each vertical industry?
So I think, let's define vertical integration. An industry that is not vertically integrated has different providers at different levels of the stack, right? You might have 3 or 4 hardware providers, 3 or 4 middleware providers, 3 or 4 system software providers, and then a whole host of application folks on top, okay? The computer industry has enjoyed that for quite some time. And the data center environment, while there have been certain dominant players, it hasn't been exclusive. So in terms of vertical integration of the elements of that stack, we are seeing some consolidation, where the end provider, such as Google or Microsoft, has their own software platform, they have their own proprietary hardware platform, they have their own installations, their own payment services, the whole enchilada. That's what I was referring to in terms of vertical integration. Now, you ask sort of a different question of, gee, in terms of in different verticals, meaning different industry domains, will there be different systems for those things? I think the answer to that is probably not. I think there will be a common set of things, but certainly we have built collections of, well, I should be a little bit careful there. We have built collections of software on top of common platforms for different parts in the space, whether it be healthcare imaging, whether it be self-driving vehicles, whether it be high-performance computing. But we also have, with NVIDIA, have differentiated with sort of different hardware platforms underneath. We have a self-driving hardware platform on which the software SaaS system sits. It relies upon the same chips and other components that some of the other hardware platforms do, but it's been targeted towards that particular vertical. So I'm not sure exactly if I'm answering your question, but that's sort of how I view the world in terms of those two different definitions.
I think we are early in the game of machine learning to see where it will go. There is a lot of fragmentation, not just in the verticals, but also in the different technologies. We have so many types of different networks, and new structures are actually being still innovated. And it's just too early in the game to see where it leads, whether to some kind of standardization or fragmentation. So again, we'll have to wait and see. That's my opinion.
All right. So let's thank the panelists again.